That would be silly. Okay, solving. Guys, stop, please. Systems of two equations. I'm going to just give you a problem here and see how well you can access your memory. And attack. Nope, just hold on. I know, I can't get it to stop. Speaker, it starts to go. Time. Come on, man. Do it. What you have or what you did. So, the answer is 3, -4. Everybody tell me what. So, I could just leave it y equals 2x minus 10 and use that as a substitution for y in the equation. And then that left me with an equation that didn't have any y's in it, just x. So I could distribute, add like terms, do all that kind of jazz, and end up with an answer for x, which was 3. And then once I have an answer for one of my two variables, I can plug that back into either of the two equations I want. You think is going to be easier. It doesn't matter. Both will work out, though. And then solve that for y, and I got -4. Okay, so that was the method that I felt like was easier. There's another method for doing this. Yeah?
Do you have to have them as coordinates when you finish?
Yes. We're going to write them as coordinates when we're done. Yeah. So there's another method for solving these things, and what's that called? Remember? Elimination. So there's 3 physical dimensions.
For an equation.
Oh, you would have X, Y, Z, and W. Mm-hmm. Yep. Okay, it's a good question. Why do we not start with W? Because it's alphabetical, right? Because we chose X to be the one we always use. So X has to be first.
But why didn't we choose W so that we'd have room for
I know. Hold up, I'm explaining. Okay, the reason why is that we live in a three-dimensional world, right? So we will typically only use up to 3 variables to describe things in our physical world. X, Y, and Z gets you to the end of it. So that's why we do X, Z. But then sometimes we might want to do a fourth variable for some reason, and we'll show you when you do that. But so then we need another letter. So do we like wrap around and what? So they just said, make it W. So the point. So anybody tell me how I do elimination? What I should be doing here first to start it off? Yeah.
You have to like X's have like the same coefficient and then subtract or something.
Yeah. Now it doesn't have to be X though. Y. So I need to multiply so that one or two variables end up with the same coefficient. And then she said, and subtract them. And that's kind of, well, partially true too. Because you could subtract them or you could add them. Whatever it takes to get that variable to go away is what we want. We're trying to eliminate a variable, right? See a method here that might be like an easy way to do that? Yeah.
Did you multiply the first equation by 2?
Front. That's not bad. That's still easier. Based on how add the two equations together or subtract the two equations from each other. Add them up because if I y. So by doing that simple equation, x, and then the rest of it's the same. You plug in your x, find your y from there. Answer. Okay. This is easier. Correct. You would keep repeating this process until you get more and more variables to eliminate until you is the idea. Mm-hmm. I just wanted to show you some specific cases. This one of those two methods. Just looking at this one, which substitution? Substitution, okay. I think both are actually not bad, honestly. But you want to do that? Multiply the first equation by 2. Yeah, you do. Just happened.
We get a 0 because
Yeah.
Yep.
What the heck? We broke math.
We're both good. Elimination would be our friend.
It is. But
Oh.
in this situation, what we have here is no solution. Doesn't work. What this is telling you is that possibly equal -8, so there shouldn't be an answer to this thing. There's no x and y that are going to make this thing work. Now, physically, what does this look like if there's no solution to these two lines? Nope. Remember, they're lines. It's just two lines. They're parallel. Remember, when you're looking at a graph of a system of two lines, you're looking parallel to each other. They will never cross. Okay? So, okay. Now, there's another situation that's, which would be if the two lines are actually like right on top of each other. How many solutions are there if the two lines are right on top of each other? Infinite number. So what does that look like? One, right? Variable, add or subtract. That is a true statement. It is a true statement. No matter what x or y you were to put into this thing to start with, it'll be the same. Because without, if we were, and its associated value y, then would work. Yeah. In an elimination, you pick. I don't care. Whatever method you want to use that you like. See, I like elimination. But substitution is still important because if systems, we're going to get out of the linear realm here for just a minute. You have substitution. Well, the rest of the chapter is all linear, but there's this one little blip on the screen for this section that's not. But the problem is, if you have something that's now, do you see elimination is not going to work for this one? You can't multiply one equation and then add them and get rid of something because they have different somethings. They have different types of variables from one to the other. So you're not going to be able to really cancel anything without leaving behind something else that's still going to make it a problem to solve. So elimination doesn't really work with this, so we're stuck with substitution. Substitution can the next one will or like polynomial type equation like you've done in the past. Remember, ordered pair associated with it then. So plug it back into one of the two equations you started with. Again, it's a system, so it shouldn't matter which one you plug into. You should get the same answer. Okay? I think this is a good one. And we can visually inspect the solution that we just came up with. Should be crossing at those three places.
And we gotta put it back to the function.
Yes. He is just all kinds of warm fuzzies, isn't he? Anyway. Yeah, I made my Y scale just a little bit larger so I could see it better. Yeah, that's good. Alright, so cross. Mine looks something like that. Okay, so do you see the solution 3, 9? And do you see negative 3, negative 9? They should all be there. Those are the 3 points where those two graphs cross. Because remember, when we're solving linear systems, where do the two lines function? Okay, this equation is linear. Do you guys see that? Can you recognize that? Okay, what do you look for to be able to tell if an equation that's written down y are separate terms? And you don't, well, no variables in the denominator. And they all have degree of 1. Yeah. Can you put the form of y? If you can, with all the you like that, how do you know that one's nonlinear? They're multiplied. What? Yeah, yeah, exactly. For y, which actually we'll do, you end up with x in a denominator, right? Which is also something we said can't happen if it's a line. Here again, we can't do elimination of variables because the x times the y screws the deal there. And substitute it in for y into the first one, and then see if we can use some algebra to get us the rest of the way through it. Have you tell me. Maybe raise your hand because I heard 3 people at the same time.
They all said the same thing.
Well, I couldn't. That's like what, right? Just get rid of all. But now's fine too. Yeah, get rid of those. Yeah,
You need to add those two.
we do. Mm-hmm.
Make X right over X.
That I'm going to solve. 2. How about somebody who has an answer? What now?
Cancel the X's.
Cancel. Just cancel. Okay, somebody else hasn't offered up anything just yet. Subtract over? Okay. So now we got x 0. Okay, somebody else. What am I going to do now? Two numbers that multiply to 300 but add to negative 50. Maybe? I think so. Nope. Nope. Can't factor it. So, you could, but nah. There's a much easier way other than completing this quadratic formula. Or graphing it, if you had a... Yeah. Three hundred is 1200. 1200 is 13. No. So, using the plus, 50 plus the square root of 1300, divide that by 2, so 1 minus 50 minus the square root of 1300, divided by 2. Then we might get this quadratic thing happening. So, and most of the time, that's actually where you're going to end up, is you're going to end up with some kind of a quadratic equation along the line there where you'll have to, if you can factor it, or right, yeah. Easier to do this. So 43. You just bring the other one? Yeah. So those should be opposites of each other there then.